morning. Oh, let's try that one more time. Good morning, everyone. Even better. Happy Halloween. Happy Halloween. It's really good to be back here, but I'm sure some of you are kind of saying to yourself, it's Halloween. We saw these guys 11 months ago. Why are we back here at the New York Stock Exchange? Well, a lot has changed in the last 11 months, and we're really excited to tell you about it today. The way you should think about this is hopefully there will be more treats than tricks today. I think what we want to talk to you a little bit about, we're going to outline our plans to expand capacity. But I think it's super important for us to spend a little bit of time today understanding the dynamics of what's driving that decision to expand capacity. And it has a lot to do with electric vehicles, and it has a lot to do with this exciting partnership that we announced today with Jaguar Land Rover. And I hope on the way in you saw those fantastic cars. The best questions today will win one of the cars, so think very creatively. And I'm sure Jacob and Santino and the team will be happy to let you take those cars home with you. But let's talk a little bit about, first, forward-looking statements. We're going to be talking a lot about the future of the business. Neil's going to give you an update on the long-term outlook. So Brad, our general counsel, would like me to read this, so just bear with me for about the next 6 minutes. I'm kidding. That is a trick, not a treat. But let's talk a little bit more about what we're going to go through today. First of all, Greg is going to give you a strategic update on the business, tell you where things are at, some of the things that we're kind of observing in the broader market. Then we're going to have Elif Balkis come up and talk a little bit about silicon carbide technology. She leads our research and development for materials, so she's got some really exciting things to share with you. Next, we totally appreciate there's a lot going on in operations. So Rex and Missy and Adam and Lisa are going to kind of give you an update across operations and how things are going. And I know you're all very keenly interested to hear what's happening at Mohawk Valley. Then we're going to take a break, and this is a good opportunity. You know, the members of the senior leadership team are here, some of our, our leaders in various areas of product and technology, in sales, and we invite you to go outside. We're going to give you about 30 minutes to interact and catch up with those folks, and then we'll come back and we'll get a financial update from Neil and an update on the longer-term outlook. Then finally some Q&A, but one of the things that we're super excited about is that Thierry Bolloré, from the Chief Executive Officer of JLR, is going to join Greg for a fireside chat and talk a little bit about not only the exciting things that we're going to be doing together, but also give you some insights on why I picked Wolfspeed. And we think that there's a great story to tell there. So at this juncture, I'd like to now turn the mic over to Greg. Greg?
All right, well, thanks a lot, Tyler. Welcome, everybody. Really appreciate you joining us today. And I want to kick off with the announcement that we made this morning. We made an announcement of a joint partnership together with Jaguar Land Rover as they move in a direction of their new strategy, which is the reimagined strategy at JLR, moving towards a electric-first platform and an all-electric future for the Jaguar brand. We're super excited about this. This is more than a supply agreement. This is a partnership that encompasses a lot of different things. We're thrilled today to have with us members of the JLR team, Francois, Jacob, Santino, and Joe. Just raise your hands here. They've all joined us here today and will be at one of the conversation kiosks. And then, as Tyler mentioned, later on today, we'll have a fireside chat with Thierry Bolloré of JLR. We've been partners with JLR, and we've been working with JLR since 2017, and this takes us into a completely new level and a new opportunity. Super excited about that. And JLR will be supplied this material for their next generation vehicles through our new Mohawk Valley 200mm factory. So thank you very much to JLR. We're very, very pleased about the announcement. All of those cars that are out front will all be moving to an electric platform, and they'll all be utilizing Wolfspeed silicon carbide. So super excited about that. So thanks again for the JLR. How about a round of applause for the JLR folks? Thank you very much. You know, a year ago we had this meeting, and I told you that I went for a bike ride. And it didn't turn out all that well. Many of you know I broke my shoulder, tore this and that, and all sorts of things. And the issue is I wasn't focused on the right thing. I was looking around and not focused. And I talked about how we as a company, we're going to focus the business and focus on this opportunity we have in front of us called silicon carbide and the electrification of so many different things and the need to do and transition to an electrified future in a much more efficient way. And that's essentially what we've done over the last couple of years over the last year is focus the business on that opportunity that's coming out right in front of us. So last year I took a bike ride. This year I went on a road trip. And I decided, you know, we're part of this whole electrification of vehicles, and you hear so many different things about what's good and bad and so forth about electric vehicles and range anxiety and all this kind of stuff, that I decided to test it myself. So I went on a 1,300-mile road trip. I took my car from Raleigh, North Carolina, up to Cleveland, Ohio, and back, and I learned many different things. Probably the most important thing I learned is that a long-range car helps a lot with range anxiety. And so I think range is going to become one of the key deciding factors of vehicles. In fact, from 2011 to 2021, the average range of an electric vehicle has increased 3.5 times. And now the range of the average electricity is about 60% the range of an average internal combustion engine car. And that gap has been narrowing, and it's projected to go to zero at some point in the near future, next 5-ish years. So pretty amazing, 3.5 times. And the longest range electric vehicle in 2021 compared to the longest range electric vehicle in 2011, that range has increased by 4.5 times. And that's in 2021, and that was a 400-some mile range. Just this year, a car has been released to market with a 520-mile range. So range is a really important thing because it kind of gets you out of this mode of, oh my gosh, what if I get to this next station and it's not working? Well, when I took this trip, it wasn't a bother to me at all because I knew if the station wasn't working, I could get to the next one. So I think range is going to be a key compelling factor for electric vehicles. The second thing I learned is that charging stations actually work. The infrastructure works just fine. I had no problems charging. There were roughly 10 chargers at each of the different stations that I stopped at. Although I only needed to stop at one, I stopped at 6 just to see what it was like. So that's 6 times 10, there were 60 chargers there, 58 were working. No big deal. You know, so that was working just fine. And I think actually the charging infrastructure is probably good for about 3 times more electric cars. There obviously needs to be improvement to the infrastructure as we become all electric, and I know there's a lot of work going on there. And I would say that the other thing that was really interesting is that I only spent 20 minutes at every charging station. And I added between 150 and 250 miles, which is quite a bit. 20 minutes, not that big a deal. And it was quite an enjoyable time because it turned out charging was kind of a social event. People got out of their F-150 and showed me their car, I showed them my car, and so forth. So the time went by quickly. I will tell you there was one sort of you can't make it up story. And that was after leaving one of the charging stations, I happened to pass a guy who was walking back to his stalled vehicle with a can of gas. So, you know, I guess range anxiety is also with internal combustion engine cars. What also has happened in the last just 4 quarters, 1 year since we were on this stage here, is that the investment by the car companies into the electrification of their powertrains has continued to accelerate. We had noted that last year at this time that there was $330 billion worth of investment that was publicly announced by car companies that were going to happen over the next 9 years or so. That number has now grown to $500 billion. And that's just the publicly announced numbers. I'm sure there's lots of other investments that are going on. So this momentum continues to build and build and build towards the electrification. And that's going across all different kind of companies throughout the world. And so what we're seeing in our business and what we've seen pretty dramatically, especially over the last 4 quarters, are 2 pretty significant trends. One is the increasing acceleration of the adoption of electric vehicles, the pulling in of the demand and the increasing acceleration of the adoption of EVs, and the increasing adoption of silicon carbide in EVs. You know, when I started at the company 5 years ago, you know, there was really only one company doing a whole lot with silicon carbide. Today, you know, I can't say 100%, but when we talk to customers, you know, their minds are all on silicon carbide. And so this debate of whether it's going to be silicon or silicon carbide is pretty much by the wayside. And so you're seeing a pretty significant adoption of silicon carbide. So you take the increasing acceleration of the units and the increasing acceleration of the adoption, and that translates into a pretty significant and steep ramp for silicon carbide opportunities. This happens to be a Cowen report showing a 39% CAGR over, you know, the next 5 years or so. You know, there's a lot of different numbers that are out there, but the bottom line is that this CAGR is going to be just ginormous over the next, probably through the end of this decade. And this only takes us to 30–40%, you know, adoption rate of electric vehicles. So even beyond 2027, you're going to see a tremendous adoption rate here. This is probably the steepest adoption rate of a semiconductor technology that's going to happen for the longest period of time that I've seen in my 35 years. I've never seen anything like this. And what it probably means is that the industry is going to be chasing the demand through the end of this decade. And you can see the content for electric vehicles, it's largely on the inverter. Most of the content, 90% of it's on the inverter. The rest of it's on onboard charging and DC to DC. In fact, if you look at the semiconductor content of an electric vehicle, most of you know that it's twice that of an internal combustion engine car. What you might not realize is that greater than 100% of the increase is in this circle over there. It's the powertrain, which is basically compound semiconductors, silicon carbide, largely a little bit of GaN in the DC to DC converters. So greater than 100% of the increase is going to be an opportunity that we go after. So you're going to see a tremendous amount of increase in opportunity and a tremendous amount of adoption of EVs. Now, the adoption across EVs and vehicles and passenger cars is now spreading to other parts of the industry too. In transportation, we're seeing commercial applications, we're seeing farm implements, we're seeing avionics, both for traditional airplanes utilizing electric power for perhaps getting around the airport itself, sometimes for taking off as well. There are some airplane companies that are talking about an all-electric future. We're seeing companies that are doing vertical takeoff and landing equipment going all electric and so forth. So you're seeing the transportation industry, broader than passenger cars, adopting silicon carbide. And then that's spreading over to the industrials. And we're super excited about that because that's a very, very fragmented market, covering everything from solid-state circuit breakers. So instead of the switch flipping and you go down to your cabinet and go change it, it's much more accurate, much more precise, much more modern, much more controllable solid-state switch. As an example, we're seeing buildings, server farms, you know, a whole bunch of different industrial applications. In fact, I think the previous quarter we talked about 1,600 different applications across the industrial market moving towards silicon carbide. So you're seeing passenger cars spreading to more transportation, spreading to broader adoption across the industrial industry. And again, this is driving that fundamental shift from silicon to silicon carbide. Our industry has been based on silicon for the last 50 years. There's a whole valley in California named after it. And we're seeing a transition from that technology to silicon carbide across a number of different applications. Super exciting. Now, from an opportunity pipeline perspective, you know, this pictorial, you know, kind of tells the whole thing. You know, for a long time, we were evangelizing, you know, silicon carbide, and you can see what's happened over the last couple of years. The opportunity pipeline has just exploded from $5 billion back just a few years ago to now greater than $40 billion worth of opportunity, again, across transportation, across vehicles, across industrials, you know, et cetera. This opportunity pipeline just keeps growing and growing and growing. And our team has done a fantastic job of converting that pipeline into design-ins. So here we are today, and we've got a cumulative roughly $15 billion worth of design-ins. That is 3 times higher than when we were here last year. 3 times higher than when we were here last year. And hence, a lot of, demand has been generated, and we'll talk about how we're going to satisfy that demand, as well. So this is an amazing story. It's also a story I've never seen in my history as well. This kind of surge in demand, is just phenomenal. And the team has done a great job of converting these design-ins to design wins. You see that the conversion rate is 43%. What that means is we have an opportunity pipeline that's $40 billion, and roughly $15 billion worth of customers have said, you won. And of that, 43% of the number of those design-ins, the customer not only said you've won, but they've now ramped into initial production. And that's a lot higher than I've seen in my past before. That's a pretty good conversion rate. It certainly surpasses anything we would have imagined would have been the case. So sales team's doing a great job. And by the way, you'll see several of our sales executives are here as well. So during the breaks, make sure you visit with Owen and Rick and the rest of the team. Angelo is here from Europe as well. All right, so this kind of summarizes things. Previous investor day, automotive companies we're planning to invest over the coming 8 years, $330 billion. Those announcements are now $500 billion plus, and I'm sure there's many non-announced additional investments that are out there, so who knows what this total number is. But from a direction standpoint, you can see it's nothing but up and to the right. Opportunity pipeline more than doubled from $18 billion to $40 billion, and the cumulative design-ins, there's that tripling that I was talking about. In just the 4 quarters that we've had 4 record quarters in a row of design-in. But when you add it all together, it's 3 times than what we had in the entire previous history since we started measuring design-ins. So pretty phenomenal success. Okay, so what that means is we got a whole lot of giddy up to do to put a lot of manufacturing in place to satisfy this demand. So we've got several different areas that we're working. First off, we have our capacity expansions in our Durham materials factory. And you can see pictorially, if you take a look at our Durham factory today, that kind of represents the size. You can see we're going to do a 10x increase by introducing our new manufacturing plant in Siler City. Rex and the team are going to talk a little bit about where we stand on that. I can tell you this, we announced that at the governor's mansion on a Friday, and on Monday, there were a bunch of machines on that site, ripping out trees, moving earth, doing things. So we hit the ground running right away on that site, and that site continues to progress today. This will be the world's largest silicon carbide factory, materials factory by far, and it'll also be a highly automated factory, and that is not the case today in our materials operation. We have some automation, but this will be kind of grounds up automation, which ought to drive scale, which ought to drive costs, which ought to drive quality, et cetera. And then finally, our Durham wafer fabs, Missy is going to talk a little bit about the progress that we've made in those fabs. Adam's going to give you an update on how we're standing on the Mohawk Valley ramp. Both are good news, and so that's all for the near term, but we know we're going to need a new fab. Neil will talk a little bit about the timing on that, but basically based on the amount of design-ins we've got, the interest in silicon carbide, the ramp schedules, et cetera, that factory will need to be up and running by 2027. And if you back that up, it means we need to start doing something in 2023 for that fab. So you'll see a little bit more detail on that. Our intention is that fab, that graph of that fab is exactly the intention of it. We have in Mohawk Valley the world's largest and the world's only 200 millimeter fab. The next fab will be bigger than that, just based on the demand we're seeing across all of the different applications. So exciting stuff going on inside our company, inside the industry. This $40 billion opportunity pipeline that we have is likely going to continue to grow as more and more industries, as more and more companies switch over and realize the potential for silicon carbide, you know, there's an interesting little side benefit to that. Almost all of our customers have some kind of carbon neutral greenhouse gas emission goals, you know, et cetera. And silicon carbide, when they put it into their application, substantially helps them improve their ability to hit their goals by certain dates. And in some applications, using silicon carbide over silicon is a 50x improvement in being able to do that. And that's been studied by third parties, you know, and so forth. So, you know, this is another additional benefit: lower cost at the systems level, better efficiency, and my ability to meet my own ESG goals way enhanced. We're seeing, you know, an incredible expansion of our capacity that's happening as we speak. And, you know, you'll get an update on how things are going with Mohawk Valley. And we're seeing the adoption of silicon carbide in all sorts of new markets. And I think what's one of the things that's really been important for that aspect of it is the partnership that we've had with Arrow Electronics. You know, they've been a terrific partner with us for the last 5 years. You know, we don't have a huge sales force. They have the largest sales force in the world, and we've been partnered with them for the adoption of silicon carbide across that broad range of markets. I talked about 1,600 different opportunities. There's zero possibility we could have gone after those opportunities ourselves. So we've got this extensive partnership with Arrow that's helping us do that, and we're super excited about taking that to the next level. So with that, what I'd like to do is turn things over to Elif Balkaz. Elif is in charge of our R&D activities and is specifically in charge of the 200 millimeter program. She had a lot of weight on her shoulders when we started putting all of our plans in place, and I can tell you she's delivering really well. Please welcome Elif Balkaz.
Thank you, Greg. Hi, good morning, everyone. Thank you, Greg, for the really nice strategy introduction and introducing me. I'm here today to give you a perspective on the silicon carbide technologies, and we'll talk about a lot of challenges and what we do about them. And we will also talk about how our technologies at Wolfspeed respond to our market opportunities. I'll talk about a little bit about 200 millimeter, how that program is going, and we will be looking at it, some really strong data. I would like to start by introducing myself. I love technology in application, and working with heterogeneous teams are important for me. I personally strive to be an invested leader in the technology field, and I take reward out of collective achievements, especially in the areas that are in difficult technology areas. I've been in the silicon carbide technology field for more than 20 years, mostly at Wolfspeed. I wasn't there from the beginning, but I really learned from the best, and I continue to do so every day. I spend most of my time with the crystal growth technologies. But I did my PhD also in wide bandgap materials at NC State, and I also completed the executive education at the Wharton School. My personal interests are mainly in the product management and strategy and scaling a business, and also leadership development. And I'm really excited to talk to you about the silicon carbide technologies today. But before that, I would like to also talk about us as Wolfspeed for a minute. We are the leading pure-play, vertically integrated silicon carbide company in the world. We do grow on our own crystals, silicon carbide crystals. We wafer them, and then we start building the device layers depending on the end application, already with the epitaxial process. And then we take those wafers and then fabricate them, and then to create the bare die. And then depending on the application, we create the devices. Those are our package devices, whether MOSFETs, Schottky diodes, or modules and GaN devices. So just briefly, what is silicon carbide? I think to me is an amazing material. As a material scientist, that I'm amazed and fascinated by its amazing properties. And a leader in technology, I'm also excited that we are able to harness the benefits of this beautiful material to make our world a more sustainable one. And silicon carbide is a combination of silicon and carbon, basically, in the crystalline structure. And it crystallizes at a very high temperature. I think if I give a perspective here that I think this room is about 20 degrees now, you need to heat it up to 2,000 and 2,500 degrees Celsius to create silicon carbide crystals. Silicon carbide inherently can take many crystalline forms, but for the power devices that we're all interested in one structure. And then we'll talk about this in the upcoming slides more during today. But what I want you to take away from here that you take the elemental silicon and carbon, you take them in the most pure form, and then you're able to heat it up to 2,000 degrees. But the materials still want to do that. This beautiful picture that you see, that bunch of little crystals, shiny, they're looking beautiful, but they're all they want to go in all different directions. It's kind of like the party going on there, if you will. But we want that you see the bunch of wafers stacked in there as well, in front of the anneal furnace. We want that. We want the wafers to be 200 millimeter, just one structure that we want for the power devices, highly uniform through the wafer. And we want many of those wafers all to be the same, and we want them in the high volume. And with our 35 years technology of experience that we will be talking about, that we can do that. And in turn, this turns out to be our strength. So these wafers, they can be electrically conductive and as well as insulator. And silicon carbide material inherently has outstanding mechanical, chemical, and electrical properties. And it's rare that it has it all together combined, all three of them. When you look at the electronic materials, that you see usually one or two of the properties combined. But as I said, silicon carbide is rare that you find them all together. And that makes silicon carbide a very actually attractive material for a variety of applications, not only for the power applications such as ceramics, abrasives, or as well as the medical industry. But all in all, silicon carbide is the ultimate material to design and build power electronic devices, as well as optical and RF devices. I want to dive a little bit deeper into the producing the silicon carbide materials for the power applications, and then producing them at scale. It can come with unique challenges because of the material properties that we just talked about. But when managed with our unique technologies, it can also turn into a significant advantage for us in the competitive field. We talked about the growing silicon carbide crystals. It requires a very high temperature. We talked about 25,000 degrees. I want you to take a moment to imagine what that means. It's basically hotter than anything that you can imagine or describe the hot. I kind of use the analogy that it's actually the surface of the sun. The temperature is about 5,000, so it's half of that temperature. So if you can imagine this in the not even the industry, but the lab environment, imagine this temperature from the equipment and the infrastructure perspective. It's very challenging. But when we talk about the material itself, the silicon carbide also doesn't melt. So let's say that you put the infrastructure, you heated up the material. Instead of melting, material goes straight from solid into the gas phase, and that requires extra controls, extra attention to the process conditions so that you can build that one structure of silicon carbide. And here on that actually right top corner, that you see the silicon carbide structure that we want to have for the power devices. This is one of 200, as I mentioned. And here you see the dots represent the atoms of silicon and carbon, and then they're actually perfectly stacked together to form that structure that we want. But remember, just a minute ago, we also talked about how they like to kind of party, especially at that temperature. So all in all, the message that I want to give you or bring home here is that producing silicon carbide materials for the power applications or the industrial applications really require experience, proprietary tools, as well as the processes. And our wafers at Wolfspeed, we recognize and we demonstrate that they are very critical for designing and for the high performing and the quality of the devices. And at Wolfspeed, recognizing that, and then with that really the goal over the 30 years that we have continuously refined that low defect silicon carbide processing and the technology. Okay, how we do that? I like, this is one of my favorite charts that it talks about how we approach that and how we developed it and what we have done over the past 35 years. So the starting seed is very important for us. We expand and we create our own seeds. Our seed stock is one of our alpha assets at Wolfspeed. And then we apply those seeds to our high quality growth. And then the way we explain that is that we have two goals there. Don't add new defects while you grow the crystal. You start with a high quality seed, but then during the growth, reduce the existing defects. Then we get a really high quality crystal, and then after that we slice those crystals to make wafers, prepare the surfaces. We do, of course, at every stage that we do a lot of analysis and control, and then we look at those wafers and to produce high quality wafers. But we, at the same time, we take the best out of that material and then turn them into seed and then cycle them back into our process. So for us, the cycles of learning enable the continual optimization of the production. So every time, each time this wheel turns, we learn a little bit and then we get better. And also that our volume, of course, it accelerates that. We do that at a high pace. I want to build on the volume part of it a little bit, talking about the 200 millimeter. You heard us talk about the die count advantage of the large diameter silicon carbide wafers. Notice here that first of all, our graphs are here based on the 32 millimeter square die size. And then when we look at the 150 millimeter to 200 millimeter in comparison, notice that the number of whole dies, it almost doubles. But we, at the same time that we gain from the edge effects, that we reduce the percent edge die, the wasted material, almost in half. So by going from 150 millimeter diameter to 200 millimeter, we create more devices from a single wafer. And then you heard us, as I mentioned it, Neil talked about that what it means in terms of the cost and the fab advantage. But you can also imagine that to get that advantage, when we go from 150 millimeter diameter to 200 millimeter diameter, we also want to of course, to have the quality per area to be identical between the two wafers, so you get the real benefit of that enlargement. In materials, we have a bunch of indicators when we expand the diameter or when we look at the quality of the material before we send it even to the fabrication that we pass the material through those gates. I want to talk about just one of them today, that is micropipes. It's a fundamental structural defect in silicon carbides, and it's also the killer defect for the devices. What we do here is that we basically look at a hypothetical map of the silicon carbide wafer. We look at it by the 5 by 5 millimeter the dimension dies, and then we look at the whole surface, characterize the whole surface. And then when we see a micropipe there, we label the die, and we don't even build the device there. So it's basically tells us the projected fab die yield. Here we see it going from 150 and 200 millimeter. we see a really good quality as we expand the diameter. You see actually only one of the pipe in the center. The center pipes are more difficult for us to clean, but you also see some issues on the edges. We feel really confident and that we're really there with our quality. And then what it means for us, when we talk about the volume and our technology and then scaling the technology, I want to talk about two charts in contrast, but also to tell you about the status or our technology capability. First, looking at on the left-hand side, that chart is that the vertical axis of the chart is a normalized volume. We normalized it to 2016 because, as also Greg mentioned, that we see that really that increase in scale that more in the recent years. So we take the 2016 volume as one, and then we looked at how the 150 millimeter volume has increased over the last 5 years. If you notice that we increased our volume by 15 times in the last 5 years. And then when we look at the right-hand side, and then we talked about the technology, how the technology is looking, and then the technology readiness, we're basically doing the same thing, but then when we look at it at the last 2 years, and then still normalized to 16, it's very exciting for us that we're already at the 2016 volumes with the 200 millimeter technology. Okay, and then so that summarizes for me and for us that that shows us, I think, that the silicon carbide is the new generation of the semiconductors. It's here. And I work every day with the individuals that are like 30 plus years that they've been working, and it's actually very exciting. It's right now it's happening. At Wolfspeed, our combined expertise, technology, and volume is basically unmatched. That we don't see any close competitor actually that near us. Looking at the 200 millimeter quality. And we see that it's equal or better than 150 millimeter, giving us the true advantage of the die count at the fab. And we see that our volume is already increasing, and our technology is ready for that because we show a really strong outlook for the technology performance. Thank you so much.
Elif, now for the fun part. How about a little Q&A? Please have a seat. And what we're going to just do is just talk for about 10 minutes or so before we move to the next presentation. But a lot of really good content there, so thank you. I think, as we sit here, though, and we think about things, how do the cycles of learning and the vertical integration kind of play into the opportunity for us in terms of being able to continue to lead the market, both from materials perspective, but then how that plays into devices? How should we think about that a little bit?
Mm-hmm. Yes, thank you, Tyler. As I mentioned, that as we produce, so we start with growing the crystals, slice them. There's a lot of data for us. We look at the performance. We look at the product performance a lot, and then our vertical integration gives us a lot of very quick feedback. Mm-hmm. And then our internal fab is our customer that we value, and we look for their feedback, and then take that feedback to our process, and then keep learning, and then keep turning that wheel that I mentioned.
Terrific. Mm-hmm. That chart that you showed us at the end there with that compares 150 versus 200, why do we think, or what should give us the confidence that we'll see a similar trend that we witnessed on 150, what you're seeing so far with 200? Mm-hmm. Because that seems pretty important.
Yes. So we have a technology, I kind of call it very mature now. Mm-hmm. Over the 30 plus years that the work that we've done on the several different diameters, and then 150 was the last diameter. But then our technology refinement continued while we expanded the diameter. But then seeing that 15 times increase in the volume, that tells us that it's actually our technology is very robust and it's ready. And then what we do when we carry it to 200 millimeter, we kind of take the same of the technology basics, foundations, but add to that in terms of diameter and the quality. And then from there, actually, our history actually speaks, I think, that the technology readiness.
But I think the takeaway is these things can't be rushed, right? Is that fair?
Yes, correct. And it takes time. The material itself is very difficult to grow, difficult to process. It takes time. We actually have, it's actually reminded me, Tyler, that we have very senior scientists that are coming from the academia. They're still there within our company, that they're supporting the new scientists in our organization. One of our leading scientists said that you have to rush slowly. And then we just go by that. We have to rush slowly. So you need to take your time to look at the data. But our volume is the pace for us.
And I think that's probably what's underappreciated a little bit, because as, you know, given our scale and what we're able to produce, I think that uniquely positions us, right, in terms of being able to move the technology forward as quickly as we can.
Correct. And now is the time, we feel like.
Very good. Last question. So we talked a little bit about, and the ops team is going to come up in a little bit, talk about Siler City, but greenfield operations and being able to build capacity in kind of a new way, because we're kind of stretching the parameters of the Durham campus. But how does, you know, we haven't seen a lot of investment from our peers just yet, but how does the greenfield operations really play into some leadership for us?
That makes me think that there are two folds. Like, as a technologist, and I know that my team will say the same thing, that we love the concept of the greenfield, because based on what we know and what we learned, that we can go and implement, and then that we can build this, you know, the perfect factory. That's great from the greenfield perspective. But from the scale perspective, I think, in my opinion, that you kind of need to know what you're going to put there, because it's, you know, the plane and it's out. Carrying our, I think, expertise, but you're going to invest a lot of, you know, the infrastructure there, that combining those, and then when you put it, that knowing that it's going to work. I think that is our differentiator compared to our peers that are going to come in. Of course, that they will want to, I think, to create the same, but then putting it all at the same time, within the time we need, I think will be the key.
Terrific. How about one more round of applause for Ella? At this time, we'd like to invite Rex to the stage, talk about ops. Very well done.
Sit there. Let's go.
Yeah, good morning, everybody. Great to be here. About a year ago, as Tyler mentioned, I stood up here. I'd been in the role for a few weeks at that time. So it was great to greet the team and really talk about our team and our plans. If I look back in the last year, I'd really characterize the main thrusts of our activities in really three areas. First one was to build a world-class team and a world-class operations excellence culture. And we'll talk about that in a second. The second one was to really leverage our existing fab and materials footprint to drive the kind of growth that we needed to fund the future. And I think we've achieved a lot of that over the last year. And then the third one, obviously, and this has gone through a number of iterations, was create a long-range plan to enable the vision and the growth for silicon carbide and device manufacturing that we're developing. I could tell you that plan has we've called it, as we say in football, a lot of audibles along the way over the last year. As we've seen that plan grow and seen that design-in grow, I would say right now we have actually either in the planning stage or in the execution stage 6 footprint activities, whether they be greenfield or brownfield. And so we are not resting. We are moving quickly and executing to a lot of those plans. We've got a great team up here to talk about some of those plans today. As I mentioned, I I joined the company about 3 years ago, first to help and lead the Mohawk Valley activity we have up in New York. Moved into the current role about a year ago. I'm going to introduce Missy Stegall. She'll come up and speak right after me. I mentioned really leveraging the existing footprint. And for the fabs, that's been what Missy's done over the last year in our North Carolina footprint, driven a lot of the great device growth we've seen with really that operational excellence and what I call MUI, right? Getting more out of the installed base. So she's done a fantastic job of that. Missy has 20-some years of experience, both with us and Texas Instruments prior to that. We'll introduce then Adam. Adam is now leading all our activities up in Mohawk Valley. Adam really went up there with me about 3 years ago and concurrently helped lead the building of the factory, the pilot lines we created to enable the automation that's going to be game-changing this factory, and then also the pilot line to create the 200-millimeter processes that we'll be employing. We're already seeing very good results, and Adam's going to talk about some of those results. And then finally, Lisa Fritz. Lisa leads our global quality. Lisa also has a very well-rounded background from TI and fabs, global quality operations. Lisa's going to talk about the metamorphosis we're going through when it comes to automotive quality. Greg talked about the inverters. Our key thrust and our key growth area obviously is in the automotive space, and we all recognize that we've got to continue to get better and continue to improve and step up to the bar and the automotive expectations. We also have 3 other members of our team that are here today. Tom Agron leads our global facilities. Michael Daly leads our materials operations. And then, I'm sorry, we've got, who else do we have? Please raise your hand. Just for all.
Joe.
Yeah, I'm sorry, Joe Roybal. Joe Roybal. Joe's also in the back. Joe leads our back end. Joe joined us also from TI late last year, and he's doing a lot of things again to leverage that existing footprint. So as I mentioned, the culture, the underpinning of that culture being our one pack culture is really key. We're starting to really leverage that over the last year, and it's really 4 major concepts. It's excellence, it's family, it's scalability, and it's passion. And the best probably way to really summarize that is it's all about a safe, right, fast mentality. Elif talked about the types of operations we have. They grow half the temperature of the sun. Things we have to really focus on the safety side. Doing things right really lines up with our quality aspirations for automotive. And then having operations, fast turns, being nimble and agile when it comes to prototypes, when it comes to operations, performance, and things like cycle time are things we've made a lot of good strides in the last year, but we certainly have more work to do. We like to say we like to make it personal, a personal culture, and make it personal to win, and that we're really striving for perfection. But even if we don't reach perfection, we're going to catch excellence along the way. We made a really big announcement beginning of last month, as everybody knows, to expand significantly our materials capability and capacity. Before I talk about that for a moment, I want to draw your attention to the picture at the top here. And this is the existing footprint we have for materials on the Durham campus. And this is the largest silicon carbide factory in the world currently, by far. And this factory produces about 60 to 65% of the overall silicon carbide wafer usage. And we are taking that and we are going to be expanding that by really incredible amounts. The new factory site we're putting together is on a very big site. It's 400 acres. Right now we see use of about 250 of those acres. It's going to be between 1.5 and probably 2 million square feet initially a space for what we call phase 1. We're actually showing both phase 1 and phase 2 in this picture. We're also going to build it on what we call a modular or farm-based concept, which is really going to allow us to modulate that capital investment as we see the growth, and it will allow us to grow into this over time. And I know Neil will talk about some of that. But the overall capacity is going to be about 10x, or more than 10x what we have today on the Durham site. And as was mentioned earlier by Elif, this is going to be a highly automated facility from end to end, from really crystal growth through epi, and will be really, like I said, just transforming the industry with this kind of capacity. And one more picture that really, to me, kind of drives it home here is if you look at this again, this phase 1 and phase 2, but that purple shaded area represents the current footprint that I just showed in the last slide. So pretty incredible. And we're very excited about this facility. We anticipate it actually contributing to the company at the beginning of calendar year 2024. So as Greg mentioned, we've already got a lot of activity going on, a lot of earth moving, a lot of plans that are really taking shape, and so we're very much in execution mode. And with that, I'm going to hand it over to Missy, who's going to talk about our Durham fabs.
All right, good morning. So just to put it in context, I've been with Wolfspeed for about 15 months now. I was actually brought in to go help drive our North Carolina operations. We wanted to make it efficiently better. And as part of that, you know, when Rex came on board last year and showed this, we wanted to present our world-class manufacturing footprint. And so if you look at this blueprint that we've put together today, I would say we're really going after those efficiencies that we wanted to drive. And so in the last year, if you look, we've had, as Greg alluded to, record revenue for the last 4 revenues. We've been able to decrease the cycle time at that site, again, driving those efficiencies. We've decreased it in half. We also had 67% output from Q1 of FY22 through Q4 of FY22. And so what we believe is that this blueprint that we've put together to talk about how we go achieve manufacturing excellence, it's working. And so I've listed some of the other metrics here today, but I wanted to really highlight how proud I am of our team and that we're headed in the right direction. I also wanted to share, you know, what does the overall fab capacity look like? So if you look at the timeline here, in 2021, we put in some strategic capital investment, right? But I will remind everyone that this factory was retrofitted. It was an LED factory that we have decided to go produce silicon carbide wafers out of. And so if you look with the strategic investment we've made, along with that blueprint, we've actually created 50% more capacity to date from the FY 2021. So that's what has helped us have the significant revenue increases that you've seen over the last 4 quarters. So what are we going to continue to do in this factory? We still have a lot of work ahead of us, right? So we were very open about some of the supply chain issues that we've seen. For those of you who don't know, that's normal. I've been in operations for 23 years. The reason it's highlighted so much for Wolfspeed is because this is the only device factory that is contributing to revenue today. So any supply chain issues is going to have an impact. But what my team is focused on is our process harmonizations. How do we go get MUI, which Rex just referenced, more out of installed tools? And then also, what do we need to do to go reduce our one-of-a-kind tools within that factory? So again, it's a very small footprint. It wasn't intended to go drive enormous revenue growth, but I'm really proud of where we've been over the last year. Also wanted to take a chance to highlight yields. So we've talked a lot about yields. You know, we talked about yields last year as well as part of our Investor Day. And so if you look at the 2 yields that we're highlighting here, the first one is process yield. So process yield is actually just wafers out, right? So you start a wafer and you expect to get those same number of wafers out. Well, my factory and the factories in Durham happen to be very manual. And so process yield is extremely important because it's a human-based movement, right? You're gonna hear a lot about Adam, he's gonna talk about his automation, but in Durham, we rely heavily on our people. And so the fact that we've been able to increase our process yield percentage, it's better and it's moving in the right direction, says a lot to what we're doing with our manual task reductions. We're also working on a lot of the tool stability. Again, these tools were retrofitted from LED to go run silicon carbide. And so we're continuing to work through some of the hurdles there. On the other side, you see die yield. So die yield is once we process this wafer and we're able to ship it, how many of those die actually yield? And so as you can see, again, over the last year, we've put a lot of effort into increasing the die yield from a customer standpoint. We want to get more output. We know this is the only factory reducing revenue. And so we're working through our defectivity. Elif referred to some of the defectivity we see from materials. We see it as well from a factory standpoint. And so we're continuing to drive that defectivity down. Now, I want to caution everybody, we are at the max capacity for this factory, right? So we have reached its full capability. We're going to continue to go drive the performance. We expect to see the process yield continue to improve. We also expect to continue to drive the die yield. But for our company to see any increase in both revenue and gross margins, that's really going to come from Adam and his team in Mohawk Valley. So I'm going to hand it over to Adam now so he can talk about what's going on in Mohawk Valley.
Awesome. Thanks, Missy. Good morning. So yeah, I want to really talk about, first of all, what is unique about Mohawk Valley Fab. So every square inch of the factory built in upstate New York was designed for 200 millimeter, fully automated, automotive quality silicon carbide wafers. So we've been working over the last 3 years to really design this building purposely for 200 millimeter silicon carbide devices. We're already undergoing our IATF certification to focus on the automotive quality. Really, again, focus on making sure that we are making the best quality, highest reliability devices for our customers. Missy spoke about, North Carolina, you're retrofitting a factory. All of our competitors, they're retrofitting old legacy factories. So this factory was designed specifically with the automation in mind to really deliver the highest volume output we can get for a given factory. Not just a factory, right? So we can't run, we have a great technology. We can't make product without a great team. So we've built a really phenomenal leadership team and an organization, over 300 employees already in our upstate New York factory. Individuals, I have 18 years of experience in silicon carbide. We have other individuals with silicon carbide experience. We brought in a lot of legacy silicon experience as well as automotive experience to really drive the culture of automation, high quality, high reliability. Again, we also are building this to be a fully automated factory. So we're leveraging what the silicon industry has implemented in their latest and greatest 300 millimeter silicon fabs. We retrofitted it to work in silicon carbide at 200 millimeter, which has never been done before. So again, a really great opportunity we have here in Mohawk Valley Fab. Just a quick look at how the campus is looking now. Really the take home here is we've moved away from the construction phase. So the building is done. The team that we have there is 100% focused on qualification and ramping this factory to our fullest extent possible. So how's that going? So first and foremost, our metrics are how do we get parts out of the factory, get them to our customers as quick as possible. So days per mass layer, it's a measurement for cycle time. And we're working to drive that to really world-class levels. As we've turned on tools and processes, we've already seen that come down really close to our target. And so by the end of this calendar year, we should be right on target for our cycle times. And really, we expect it to be about half of what we see today out of the North Carolina facility. And then on the right here, yields. So we leveraged all the learnings out of the 200 millimeter pilot line that we had in Albany to really demonstrate capable yielding 200 millimeter power devices out of the gate at Mohawk Valley Fab. So it's not typical. It's pretty often that you're building a new factory. You may have lots that don't yield. So I'm really excited to share that every lot that's come out for our MOSFET devices so far has demonstrated yield and really providing some good baseline for our factory going forward. And as more lots come out, we continue to see that improvement day over day and week over week. And so we're continuing to, again, leverage that knowledge from the Albany pilot line, leverage the automation, which really drives less defects, less contamination, and really quick cycles of learning to really drive that quality going forward. And so as we already have a lot of really promising results, a lot of good progress so far, we're focused on qualification, but we also really want to continue to focus on the ramp. So we're continuing to install equipment. We're continuing to purchase additional capital to really drive that ramp that we expect to see over the coming years. And just to give you a frame of reference, once we get to about 15% utilization in Mohawk Valley Fab, we're already bigger than North Carolina Fab. So just to think about that. So we have a long way to go in Mohawk Valley Fab, but just 15%, which you kind of see represented on the slide here, we are already bigger than what we're producing out of the North Carolina fabs today. And so it's really important, and again, the team's super focused on the ramp and the install going forward for our factory. And so leveraging the automation that I spoke about, leveraging the really good baseline yields that we've seen so far, you put that all together and we're expecting really a great margin contribution from this factory. So specifically, given the size, the scale, the automation, which drives not only quality and improves cycle time, it also drives a much lower labor cost. So leveraging that and the yield that we're expecting, we've already seen and demonstrated so far at the Mohawk Valley Fab, that's gonna translate into a 50% reduction in our cost per unit coming out of Mohawk Valley Fab. So really excited about what we've seen so far. Again, really good progress thus far with turning on the automation, demonstrating yields on both our diodes and our MOSFET devices. And again, looking forward to continuing to ramp up this factory. So I'm going to hand it over to Lisa, who's going to talk about our culture and our quality organization. Thank you.
Oops, thanks, Adam. So good morning, everybody. So to start, before I go into the slide, I just want to share that applications out there are becoming increasingly complex and diverse, and EVs, our friends at JLR, your cars as well. And it is really important and critical that we continuously improve the quality of our devices. And an automated factory such as Mohawk Valley is only going to help in that space. And that being said, to share from the quality side, fiscal year 23 to date for our consolidated power devices, we have met and exceeded our quality goals. Now, as we look to the future, we're going to maintain our focus on 3 strategic pillars that drive our global quality strategy, which is to integrate our people, systems, and culture to drive quality as a competitive advantage. The first is building out experienced quality engineering teams with industry experts. And we have built out my quality leadership team, and you can take that down a level as well, with key and very experienced automotive and quality expertise, and we're very proud of what we have accomplished thus far. And we'll continue to look for talent and build it out further as we scale and expand. We'll look towards improving our training methods, our problem-solving capabilities, and instilling that quality-focused mindset. And the second pillar is about investing in scalable quality management systems and processes. And I think it was 3 years ago I was on this stage. We did put together a large investment in a state-of-the-art quality management system. And that system is now fully built out and fully deployed across all of our factories. And it is scalable as we grow. You'll see it in Siler City as well. And as we look at our zero defect strategy, we will continue to invest in and standardize more processes and systems and automate wherever possible. And finally, we want to advance our automotive culture through key quality initiatives. Next, we are leading the silicon carbide industry in advancing industry standard organizations. So we have two key co-chairs on our JEDEC subcommittees. From a material side, we actually engage in the SEMI standards and, of course, the ice cream conference. And we have added a product stewardship expert to our quality team, and he engages and actually co-chairs one of the key IEC subcommittees, which is product level environmental standards. So we're hitting it on all fronts. Our businesses and our factories are automotive certified to IATF 16949. And we're on track for Mohawk Valley. I keep looking at Adam here. We are on track to get it certified as well within the year. And we have deployed industry standard metrics and qualifications. And you heard about the designs in from Greg. You'll hear more from Neil. And those industry standard qualifications are a key part of doing business and how we partner with our customers. We also audit ourselves for compliance and continual improvement, and our customers do as well. And more of our European customers, we do what's called a VDA level audit, and we've been achieving over 90%. So we're getting an A out there, so I really like that. And then we're implementing key quality initiatives, and the biggest one is zero defect strategy, and that includes things such as defect reduction focus, statistical process control, supplier assessments, and then overall we're focused on improved customer satisfaction. And one piece which isn't on here is, as a company, we are going into this automotive transformation phase across all corporate functions. So automotive is not just about quality. And that's a good lead in for my final slide on quality culture. And this one here, I want to point out, we have to go beyond processes and systems. That, along with our people, is really the foundation here. We have to have the right behaviors with active engagement, the right attitudes with that proactive mindset to really drive the culture that we must have for automotive. And to tie it back to how Rex started to our one-pack culture, that really is the ethos that we operate in our company and our factories. And we want to instill that safe, right, fast culture with our employees, as well as a sense of pride and ownership in what they do and what we produce, because when it becomes more personal, there is a greater desire to win. So I'm going to close with how Rex opened. It's a good closer. When we reach for perfection, we catch excellence. And I know our entire Wolfspeed is not here, but it is really due to them. So I'm going to close out for the team and give a big thank you to the Wolfspeed team from those of us here on the stage and in the room. So thank you, and I'm going to hand it back to Tyler.
We're do a little Q&A.
Sure.
You're not done so fast.
We're not done.
I get to sit next to Missy.
All right.
Don't worry. Easy stuff, I'll tell you. No, but I think, listen, one of the things I think as you sit in the room and you look at the team in which you guys presented today, I think the reality is how can we, as we look at this capacity footprint, think about risk of oversupply, in terms of, what we're talking about. I mean, Greg showed some great slides on demand. Neil's going to talk a little bit about what the outlook looks like, but how can we ensure that we're not oversupplying the market at this point?
Well, I think, one of the things I touched on was the modular or farm approach we're going to take in Siler City. It's a very significant footprint. It's going to drive a game-changing level of capacity for us and even for our LTA customers. But I think the approach we're taking is one that's a responsible capital approach to be able to step into it, as we go. Sure, we're going to have to work with supply chain and have to stay ahead. Things like fabs where we have very long lead time items. Now, thankfully, in materials, we build a lot of our own, our own crystal growers, so we can control that, modulate that.
Okay. Missy, what do we do with Durham once we get Mohawk Valley up and running and we're going to add Siler City capacity? How do we, you guys have been running it pretty hard, so what do you think about what we do with Durham?
It's a good question. When you go back and you think through the slides that Greg showed, and then when you hear what Neil has to show later, we have just a substantial amount of growth in front of us. And so while, Mohawk Valley is going to be automated and it's going to contribute a lot to our bottom line, there's still going to be real demand out there that we as a company have to go chase. And so for me, I see lots of potential still in Durham. There's a lot of opportunity to continue to optimize it, make it more efficient, and drive the yields forward. So I see it being around for quite a while as we continue to chase our demand.
And isn't it fair to kind of remind everybody that you were doing something similar on a much larger scale at another place? So applying those learnings is really what's helping there, right?
Yeah, definitely. I have a background in running manual factories. And so there's a lot to be said for what we do and how we grow. And, those factories can actually be a competitive advantage for companies in terms of just bringing in engineers. When you have older equipment, it actually allows engineers to be more innovative and to do real traditional engineering type work on tools. And so it's a good place to come in and, grow our team. We also have the opportunity to do some of the R&D work there in the Durham, right? So Adam and I will be able to multi-factory flow lots. Most of our R&D team for the business unit lives in North Carolina. And so to be able to have those tools in a place where they can do the work, and then we ship wafers back and forth will be really key for our growth as we continue to expand our business.
Adam, you gave a great update. It seems like the team's making great progress. How do you feel about, the next couple of quarters here in terms of, the ramp and things like that? Team feeling good, everyone not feeling too stretched at this point?
Yeah, really good progress so far. I touched on we've already seen really solid yields from the lots coming out of the fab so far. I can't highlight enough that it was kind of expected that you might not get yield on the first few lots, and so just the fact that we leveraged all that learning from Albany, we basically started out of the gate already going, and so all the yields so far have been looking really solid. So I think you take the yield piece. You take the automation So again, automation doesn't just help reduce the number of people you need. It speeds up everything. So learning cycles, how quickly can I see those signals that I need to go dial in? If I have an issue that I think might be substrate related, it's not go tell my supplier they need to fix it. I just give a phone call to the materials team and let them know, like, hey, we got to work on this. So leveraging all that vertical integration, leveraging the automation, I think things are still looking really solid for us.
That's great. Thanks, Adam. Lisa, when automotive customers come in and talk to us, we're still kind of a newer player in the device marketplace. How does that dialogue go? Do they immediately want to jump to one particular area, or what do you think is kind of the three things that automotive customers are looking for when they talk to us?
Well, one, they're looking to, and I'm going to reference that culture slide, because that is a slide that we share with customers, and I know, and more importantly, we share it internally, but they want to see that we go beyond just systems and processes, right? They want to see that we get that it's a culture that we need to drive, and that is a huge thing. When I've been with the company now 4 years, and some of the first automotive customers I met with, I showed them that slide and I'm like, okay, you get it. And I got a big check for that. Also understanding how we're going to respond, right? They know that, in this world, there will occasionally be issues. And how fast we respond to them, how thorough, that's that structured problem solving we talk about a lot. That's another key aspect they look at. And then I'm going to touch on, I mentioned the industry standard qualifications, right? How we qualify ourselves, how we help and enable them to qualify in their platforms, whatever the product is. That's another key one. We have to hit those industry standards. And I'm going to add a fourth one. And it really, sorry.
Go for it.
I'm going to go for it. It also really comes down to the people. And that's one reason I joined the company. This is an incredible journey that we're on, is this blend of, the people that we're creating now, Wolfspeed, and the external influence. You can see Rex, Missy, myself, others in the room. We've got this fantastic blend, but they see that we're bringing in the right expertise to pull everything up, at the speed that we need. So people was also a big piece of it too.
That's great, Lisa. Thank you. Rex, I think this next one's for you, but anybody on the team, please jump in. You look at what Greg presented in his slides in terms of the demand. You start to rack up the design ins. It feels like we're trying to thread a needle with capacity at this point, because it sounds like Adam's going to be pretty full a little bit faster than he originally thought. So are we going to be at a point to where capacity is going to be pinched, or how do you feel about the plan for Siler City coming up at the same time we're filling that second half of Mohawk Valley?
Yeah, I think we've not been bashful about the fact that we're going to be chasing demand, right? We know that. But the good thing is fuller factories also mean obviously better factory utilization, better economy of scale, better costs, better margins. And so we're excited about that. But we're definitely going to be in that mode for a while. And I think we've got to continue to, as Greg has pushed us to do, look at the future faster. And figure out how we solution the future faster. I think there may be some opportunities here with silicon maybe getting a little softer for us to leverage that, because we're not seeing the softening. We're continuing to see it be very, very strong. And so that is a chance for us to, leverage something that maybe wasn't there, 6 months ago. And then just being very opportunistic, whether it be working with partners like we did in New York, working with other partners we're working with right now, to not just have good sites to actually build the factories, but also the workforce, as Lisa mentioned, is incredibly critical, right? Mm-hmm. And we've already leveraged a lot of these partnerships in New York to create a pipeline of talent coming into our teams. And that, to me, is probably the biggest thing we've got to work. We'll get the facilities and we'll get the equipment right in time, but we've got to make sure we have top-notch leaders, engineers, and everything to take advantage of it. So that's a big focus for our team as well.
To build on that, what is, and Adam, you're the host for a lot of these things, but when automotive customers come in, I mean, we've announced a terrific partnership with JLR today, and when they come in to see Mohawk Valley and the facilities, what are kind of the takeaways, or what are first impressions like when they see that?
Go ahead, Adam.
Yeah, it's the scale. You know, we did pick a good site with a really good view. I see some familiar faces that have come out and visited us, so you know, happy to host anytime I can, because we love showing off the building. You know, it was purposely designed and built for 200 millimeter silicon carbide. I think, as I mentioned, every square inch of that building, you know, I'm proud of it. You know, my team's proud of it. You know, we poured a lot of you know, blood, sweat, and tears into that building, and so I think it shows well. I think the design, as I mentioned, was really well done, focused on automation, focused on, you know, not only, you know, we provide efficient products to the market, but we wanted to build a factory that was efficient. So, you know, LEED certification, recycling our own water, using robust power sources. So all the things that we designed in, you know, I think that helps, you know, when we bring customers in. They love to see it. You know, it's been really exciting, both for me and my team to show off the building, but to hear the feedback from our customers about, you know, how great of a building it is and how excited they are to start getting some parts out of it.
That's super helpful. Last question. You know, we've talked a lot about a second fab, and Adam's kind of alluding to, you know, the pace of play is accelerating up at Mohawk Valley. Probably, is it likely that in the next, you know, 12 months we're going to have to make some kind of decision on more capacity from a device perspective? Not that, you know, Missy isn't tapped out. You know, it's just, it's busy is the best way.
Certainly, I think within the next 6 to 12 months, we will definitely be making a decision to on where exactly that next footprint's going to be, and we're already actually working some of the design phases right now to get ahead of that. So I mentioned the 6 footprints that we're kind of actively either doing or planning. This is one of those.
That's great. How about one more round of applause for the ops team? Well, we've gone through a terrific amount of content. We still have a lot of great stuff to share with you. But what we're going to do right now is we're going to take a break. We're going to give you 35 minutes or so. So get some coffee. Please take the opportunity to talk with some members of our team here, and then we'll be back in the room at 10 o'clock. So thank you.
I hope everyone had some good conversations out at the kiosks, talking with the team. It was actually hard getting everyone back in here, so I assume those conversations were going well. Didn't expect that today, that I'd be waiting for the audience to come back in for this part of the presentation. But a couple things here. So I think you heard it this morning. Overall, a lot of change in the company since we spoke to you last year at Investor Day. The market has accelerated. The pipeline has accelerated. We've seen our design-ins take a different trajectory over time, and we're also seeing more revenue and investment expansion over that period. So if you look at it just last year, we talked about the power device market being roughly $6 billion. It's now grown over 50% to $9 billion. If you look at the opportunity pipeline, it's more than doubled, as Greg mentioned earlier, from $18 billion to $40 billion. And our cumulative design-ins have almost tripled from $5 billion to $15 billion. So a lot of change over that period of time. So when you look at the overall power device market, let's just drill into that a little bit. So as I just talked about, 2024 going to 2026 to $9 billion. If you accelerate that out to 2027, we see that being roughly $11 billion, primarily driven by the adoption of electric vehicles, north of 25% EV adoption rate. And if you look at the top right of the chart, 90% of that opportunity within electric vehicles is in the inverter and in the drivetrain, which silicon carbide is uniquely suited for. In addition to that, if you look at the bottom of the chart in terms of the areas that are lighter shaded, you can see that also other applications, industrial and energy applications, are also increasing. And our opportunity pipeline has increased as well. If you look at the left-hand side, 2.7 times increase to $40 billion, as well as our design-ins going to $14 billion over the same time frame, going up over 3 times. So clearly a lot of momentum in the business. You heard about it this morning from the team, and we're seeing that kind of come through. So what I want to do next is drill into the design-ins a bit. How do our design-ins work? If you look at the chart here, typically there's a 2 to 4 year design in to revenue cycle, meaning we negotiate a deal, we have some sort of award of business, so we've won some kind of award. And then it takes 2 to 4 years from that design in till we start ramping revenue. And what you have here is an automotive example. So over 2 to 4 years, over a 7-year period, you start to see a cycle where the revenue starts to accelerate and then comes down the back end. And that's generally how our deals work, particularly if you're looking at an automotive application. What this chart is here is an actual breakout of our $14.8 billion in design-ins over that period. And if you look at the top of the chart, you can see the automotive portion of that. So you can see that long tail of design-ins from an automotive perspective. And why is that important? It's important because it gives us very good revenue visibility over time. So we get very positive view of what our revenue is going to look like over a long period of time. In addition, if you go to the bottom of the chart, again, you see the lighter color. You see non-automotive applications. So those design-in to revenue cycles are a lot shorter. And that's why we see more industrial or non-automotive type of applications today that are ramping in revenue in the earlier periods. Now, the other thing to think about when looking at our design-ins is the left-hand side of that chart and how fast it's ramping. Our design-ins are underpinning our growth. We will likely be supply limited over the next portion of this period and probably out to the end of the decade based on how the market's going. But if you look out to that 2026 and 2027 timeframe, what it says is our capacity is going to meet or exceed, the demand is going to be ahead of what our capacity can meet even over that time frame. So if you go to 2026 even, we're going to see that Mohawk Valley will more or less be sold out based on what we're seeing from a design-in perspective. If you go to the right-hand side of that chart, that's where we have to continue to drive design-ins out of the pipeline. So what you can take away from the chart is a lot of revenue visibility over time as you see what we've seen come through the design-in cycle. We're seeing steady growth out into 2026, meeting our capacity limits and having to expand our capacity. And we'll start to see that come down over time, but we'll have to fill that in with additional design-ins over time. But clearly a lot of momentum from the design-in perspective. Now, what's changed from a revenue and CapEx cadence? Now, if we are going to be having a lot of supply requirements to hit these revenue targets over time, you can see what's changed. If you go back just a year ago in 2021, we guided revenue at $700 million. If you go out and look back at our results from last year, we actually achieved $746 million, so we saw it go ahead. If you look at 2026, we had roughly $2.1 billion in the outlook. And now we're looking at $2.95 billion in the same period, a 40% increase of what we thought just a year ago. And if you expand that out to 2027, we see that revenue growing now to $4 billion. Now that's also going to come with more investment. We're going to have to invest in capacity to drive that revenue growth. So last year we thought, a few $100 million of capital in 2026, or back in 2021 when we looked at this. And 2023 CapEx, when you go back and look behind. And then start looking at this year, last week in the earnings call, we talked about $1 billion of CapEx investment just to meet the higher and steepening demand curve that we're seeing for our products. So what does that mean from a revenue perspective? From a revenue perspective, that means we're going to grow at a 40% CAGR between now and 2027. And if you look at the pieces of that revenue, it's broken down in 2027 into the three buckets. You have roughly $700 million of materials revenue, $400 million coming from the RF device products. But even more importantly, you're seeing a bigger chunk of that revenue come from $2.9 billion of power devices in that period. And those power devices are going to grow at a 60% CAGR clip over that time frame. So clearly a lot of growth in the power device number over time. And the big question is, look, we see the EV adoption rates picking up. We see the opportunity in non-automotive and industrial applications and other non-automotive applications. But the real question is, how do we bring on capacity to support that level of growth over time? So this is a breakdown of our revenue related to that power device number. So what you see there is, if you look to the left-hand side of this chart, is that it's our Durham fab today. So there's a small amount of capacity today that we run out of Durham. By 2027, we'll be filling 3 fabs in order to meet that type of requirement. You see Durham at the bottom, roughly 400 million. Mohawk Valley will be full at that time frame, full utilization, and have about $2 billion of revenue. And the remainder of that would be based on another fab that we're going to announce hopefully in the not too distant future. But that also gives us an incredible footprint to continue to grow out beyond 2027. So you can see that other fab, the one we just announced there, wouldn't be full. In fact, the four-wall capability of those fabs will be greater than $5 billion if you look out into the future, and at really tremendous capital returns. So as you start to invest more tools into these fabs over time, they're going to create a really nice cash generation machine that I'll talk about here in a minute. Now, you think about $5 billion of device revenue, you also want to think about that as a backdrop of what this industry could be out in time. So if you look at the right-hand side of that chart, at a 40% EV penetration rate, this market could be looking at 18 to 20 billion even by the end of the decade. So clearly what we've built here is a fit to function type of facility and footprint we have for our factories from a capacity perspective, with a long avenue to continue to grow these out to the end of the decade into a market that's going to far surpass that as you look out in time. Now, these factories that we're building, Mohawk Valley, for instance, is not just about bringing capacity online. These fabs are terrific cash generation vehicles. And this chart here is an actual example of our model of how Mohawk Valley will work. And you can see the progression there from a cash flow perspective. Over on the left-hand side, if you look there, we're going to put net $1.5 billion into the factory. That's after the incentives we receive. You start to drive revenue out of the fab. The team talked about it earlier today. You start driving the revenue out of the fab, and you get to kind of a break-even point at 30 to 40% utilization. So cash break-even at just 30 to 40% utilization. Then, as we start to drive the fab up to full utilization, it can achieve $2 billion of revenue, but more importantly, it can generate greater than $1 billion, $1.2 billion per year of cash flow. So a tremendous cash generation vehicle. So once we put the investment in, we drive it up to utilization, up to full utilization, and we'll have an incredibly strong return over time. So we believe we have the blueprint for creating silicon carbide-based capacity. 200 millimeter substrates, we talked about it today, putting it into a highly automated fab, and then driving revenue through those fabs with a great cost footprint and tremendous cash generation potential. Now, how is that cadence going to work in terms of building out all of these facilities? And I'll talk about them in a little bit more detail here in a minute. So we're going to drive that revenue, as you see the shaded box in the back, up to over $4 billion. We announced last week that roughly $1 billion will be required in 2023, and then north of $2 billion in 2024, and then we'll start to come back down that curve over time. And the reason for that is twofold. Number one is, if you look at the chart, the bottom part of that chart is facilities-based, meaning those are fixed investments in facilities. So we'll start to build out these factories and start putting the facilities kind of fixed cost footprint into place. And then as we get revenue visibility, we'll start putting the tools in. We'll start driving those tools into the factories from a variable perspective to match the revenue capability and the opportunities that we see into the future. Now, right now, what we see is, as you look at that demand and that design-in curve, a lot of opportunity for a while. So we'll need that supply. So the plan is to continue to tool those factories out, as fast as possible. But we're going to have a fixed cost investment in facilities, and then we'll also see tooling out those facilities over time as we drive up to $4 billion in revenue by 2027. So what do you get for that? So overall, I've said it many times, it's 2 to 1 CapEx to revenue ratio. And what does that mean? That equates to roughly a $6.5 billion investment over the next 5 years, 4 to 5 years. But what do you get for it? You're getting the largest and the top state-of-the-art automated 200 millimeter silicon carbide footprint in the world. And that footprint is here to serve the industry's top customers. So if you look at the pieces here, we're going to finish tooling out Mohawk Valley that'll have $2 billion of revenue capability. We're going to add another fab, which we hope to announce early next year. That will be larger than Mohawk Valley. And we'll have Siler City, a manufacturing capability for 200 millimeter substrates wafer processing, and epitaxy that'll take us and fill all of these fabs with 200 millimeter automated capability. So a tremendous amount of investment, but also a lot of great returns off those investments as you think about the market opportunity and the cash flow generation that these facilities will generate over time. And that's what essentially the cash flow model shows. If you look at the left-hand side of that chart from an operating cash flow perspective, over time, as we build out these facilities with this great operating cash flow capability, you'll start to see the operating cash flow pick up over time, getting to over $1.3 billion by 2027. And if you look at the right-hand side of the chart, as we make investments, we'll see a decrease in the free cash flow, and then start making that transition to free cash flow positive out in 2026 and 2027, as we really start to see the benefit of these large automated facilities taking hold. Now, how are we going to fund this? I've gotten a lot of questions on the side about how are we going to fund this. So you maybe if you I see the reaction, a few people were waiting for this chart. So look, there's four ways we're looking at doing this, okay? And I would consider this kind of the order in which we're approaching this, okay? First is government incentives. We've been very active in the US and outside of the US. I think we feel very comfortable with what we've seen so far from a government perspective, and the team has been very engaged there. There's some more work that needs to be done. I think we'll get a better view of exactly how this is going to work early next year, but I feel really great about where we are with government incentives, and I would say with the passing of the CHIPS Act and the ITC, that really puts us in a nice position as we start looking forward. Secondly, we're looking at customer funding. Customer capacity arrangements as we start seeing the steepening demand curve and working with customers on payments to help us. The third bucket there is either private or project financing, and I would think of this as kind of low dilution type of financing, whether it be secured or unsecured, that we can look at as well. And then lastly, public markets, and we've done this before, whether it be ATM equity or convertible offerings and those type of things. Now, what I can say is that we're going to need to do a tranche of financing in the not too distant future. And the reason for that is our CapEx related to these new investments we're talking about today are going to start to pick up in the back half of this fiscal year. And we would like to get a lower dilution targeted type of financing completed in advance of some of those big step ups in CapEx. Now, we're in good position today. We have $1.2 billion of cash on the balance sheet, but we will be thoughtful about how we bring this to market. But also dilution will be top of mind in terms of what we're targeting and when and how we approach this. Now, from a bottom line perspective, if you look at the chart, over time, we will expand gross margins, and the plan is essentially the same. We'll drive those margins. If you look at last year at Investor Day, look at 2021, and you look at Investor Day here today, we'll still drive that long-term model to the low to mid-50s. The one change is that we have extremely high demand in the short term, not leaving us a lot of opportunity to make changes to our Durham footprint, like changing the RF products from 100 to 150 millimeter. And we're going to take our 2026 and 2027 kind of revenue numbers up, and we're going to have to run the Durham factory longer to support that. And that's going to cause a bit of a drag as well, and I'll take you through that. But overall, the basic elements of our margin expansion remain the same. And you can see that here. So if you look at the left-hand side of the chart, we'll go from the 30 to 40% gross margin range. As you move over to 2024 and 2025, as we push more revenue through the 200 millimeter footprint that we're building, we'll start to see that margin expansion come up. And then as you move out to fiscal year 2027 and beyond, we'll see that higher margin, 50 to 54%, as we continue to expand the power device business through that 200 millimeter footprint. And what we have here is just a more detailed breakdown of the margins. So if you look on the left-hand side, the main elements of our margin expansion remain the same. Drive continued improvement in Durham. You heard about that today. Expand our 200 millimeter diameter change from 150 to 200 millimeter on power devices. You heard about that this morning in terms of not just the science that the team talked about, but also the execution and the yields in the fab. And then the third piece is putting these through large automated facilities in the fab and getting that scale and benefit out of a factory like a Mohawk Valley. Now on the flip side, we're going to see some drags. The RF diameter transition I talked about. We're also taking our 2024 revenue up, so there'll be, in the short term, you'll see an impact of more mix coming out of Durham than we initially anticipated. So that'll take us to about 45% gross margin in 2024. But as you look out over the long term, those same tenets still apply. Continue to improve Durham, drive that margin diameter transition or that wafer diameter transition to create better margins, and then eventually see benefits from the cost and scale benefit that you get out of these large factories. And you can see that here. I mean, I stole the chart out of Adam's deck and kind of just stuck it in here. I think what you see here is from a Durham fab perspective, we're making a lot of progress in the fab. We have a long way to go, but we're making progress. But regardless, normally when you shift from a 150 millimeter to a 200 millimeter wafer, you get about a 40% cost advantage at the die level. In this case, because of the automation and the scale and the yields we'll see out of Mohawk Valley, we're looking at greater than a 50% cost reduction. So the path is pretty clear. You just have to continue to work with these 200 millimeter wafers, drive them through these large automated facilities, and we'll start to see the benefits down the line. Now, from an OpEx perspective, if you look over the last several years, just a year ago in fiscal year 2021, we were roughly at 60% OpEx as a percent of revenue. We've driven that down over 20 points just in the last couple of years. And as you look out into the long-term model, those targets remain the same, low to mid-20s operating expense as a percent of revenue. But that's made up of a couple of different things. The first one is we are going to continue to invest in R&D. These are heavy growth rates. We need to support our customers with new products, and we will continue to see the actual R&D spend increase over time. But our revenue growth will far exceed that, driving down OpEx as a percent of revenue. So I think that'll be a positive for us. On the other side of that, as you look at SG&A, we're driving a digital transformation, we're improving our functions, and creating scale in those functions. So over time, we'll be able to grow our revenue with just modest increases in our SG&A functions, particularly when you look at the G&A side. So I think we're creating not just a great footprint for what we want to do from a gross margin expansion perspective, but also from an operating expense perspective to scale the company, but also support our customers with higher R&D expenditures. So with that gets us to the target operating model. So if you look in 2024, we've taken the revenue up to $1.6 billion. The margins will expand to 45% gross margin, a little bit behind where we were when we talked last year, just based on those couple of items that I discussed. We'll continue to invest in OpEx, but as you look out to 2027 and beyond, a strong growth rate up to $4 billion out in 2027 with north of 50% gross margin, that 50 to 54% range. And then OpEx at 23 to 25%, kind of low to mid 20s in gross margins. But as you start to get to scale, you start to see adjusted EBITDA of roughly 45% in that time frame. We'll start to drive more cash flow through those large automated facilities and creating that footprint as you look out over time. So with that, look, I started out with it. We're expanding in a lot of ways. We're seeing the market accelerate. We're seeing our device pipeline accelerate. We're seeing more design-ins, more than we had anticipated previously. And we're going to invest to create growth and underpin those investment plans. So with that, I'll end it here, but I'll maybe invite Greg up to do some Q&A.
All right, thanks a lot, everybody. So at this point, we're going to open it up for any Q&As you might have. I think we've got somebody running around. There's a few Q&As. So we'll go ahead and, Tyler, why don't you just go ahead and.
Yeah. Brian, go ahead. Sign first.
Yeah, and if you don't mind waiting for the mic as we've got this being broadcast around.
Hey guys, good morning. Brian Lee, Goldman Sachs. I guess two questions on the outlook here. One, the fiscal 27 target of $4 billion in revenue. I think you had the slide with the design-ins and how that translated into revenue. So I know you have more design-ins coming, but it showed a fiscal 26 peak. And then you've got the $4 billion target, which you're introducing for 27. So can you kind of bridge either what visibility or what you're embedding in the assumptions to get to the $4 billion, just given the other slide that showed the sort of
maybe I can kick it off, and then So first off, that's basically a graphic of all the wins that we have and how they're shaped over time. As you can imagine, that peak has been 26 number we have. It actually, 27. We've got a pipeline of design-ins, as opportunities that are out there. We have a conversion estimate. The code we need to be.
And I would just add to that, Brian, when you take a look at the amount of design-ins that we need to continue to generate in order to hit those numbers, we only need to hit a number that was roughly what we did last year in design-ins, which was around $6 billion, I believe. Last quarter, we did $3.5 billion. So we do not need to actually accelerate the design-ins further to hit the numbers that are on the chart. But in fact, as Greg just said it, what we're going to see is that's just a profile, a snapshot today of how our current design-ins roll off. There are going to be a number of industrial and energy applications, non-automotive applications, that we will win between now and then that'll have shorter design-in cycles. So that there's a high likelihood that we're going to be capacity constrained in 26 and 27 when you start to look at those numbers, based on what we're seeing. In fact, when I showed the chart there, Mohawk Valley is completely full in that time frame. And the design-ins already support that. So we're already in a position where, from a capacity perspective, we're going to see capacity kind of chasing demand for the foreseeable future.
Yeah, I guess that's a good segue into this. My follow-up on the Siler City fab. Is it a deliberate strategy not because it looks like based on your long-term targets, you're not assuming any revenue growth in materials, that side of the business? Is that you trying to maintain that competitive advantage versus peers, or is it just you absolutely don't have the supply to have merchant capacity out of that large capacity run?
Our strategy in materials has been pretty consistent since I've been here, and that is we want to have long-term supply agreements with our customers, and to the extent that they're interested in extending and expanding those agreements, we're interested in doing the same thing. We have as a base assumption that most of those customers are going to try to integrate their own materials business, and they'll, some of them have had different targets. They want to do 40% or 50% or whatever inside. And so we'll capture whatever they have outside or they plan to get from, external sources and so forth. But our base assumption is that they're going to execute to the plans that they have in mind. And so with that in mind, Siler City has that kind of contemplated. And so another way to think about it is we're going to be absorbing a lot of Siler City inside of Mohawk Valley and the new fab, and so forth. So I think that's going to be a key thing.
Hi, everyone. Thanks for hosting this event. Gary Mobley at Wells Fargo Securities. On your SAM opportunity that you highlighted up there, I think it was $9 billion by 2026. I'm not surprised to see that's higher than other forecasts that I've seen, like Yoli's, but I think it's 50% higher than Yoli's forecast. Maybe if you can just walk us through some of your assumptions there.
Yeah, so I think, Gary, when we look across those opportunities, we kind of base those across a number of different areas. I think Yole has a number that's a little bit lower than that, but if you go back to last year and look at Yole's number, it was also a lot lower. So what we do is we take a look across a lot of different areas, a lot of different publications. But on top of that, we also work with our customers. We get a lot of visibility from a lot of the tier ones. And I think from our viewpoint, we get a really good look as to what's actually happening in the marketplace faster than maybe what's being published by publications on a regular basis because of those relationships that we have, both on the material side, but particularly on the device side when you're talking to tier ones or OEMs that are looking across the globe in terms of what they can see. So based on that, we see a little bit more from that perspective, and that's what's driving the number to be higher. If you go back and look last year, what we said, those are actually lower than where the publications are now. So I think we've got a pretty good line of sight to what that looks like.
Okay. As my follow-up, I wanted to ask about the definition between design and design win. Is a cumulative amount of design wins, is that reflected in the backlog number that you guys quoted in your 10K, which I believe
those can differ. We don't necessarily always talk about the backlog number because that's typically we've gotten a PO. Some people give a long-term PO, some people do shorter-term POs, so it's not necessarily reflective of what the design-in is. But you have seen that we have gotten a lot more POs if you look at the amount of backlog that's we've kind of posted in the K.
And maybe I'll just add just a clarifying point on that too. So we have an opportunity pipeline. That's just customers are asking us to bid on projects and work with them and so forth. And then we have a design in. A design in is when they officially award us the program, and that's done through many different instruments. Normally it's some kind of supply agreement or some kind of supply award letter or something like that. And then that's called a design in. And then a design win is when it translates from that design in to customers begin ramping up into initial production. And that's where I'm super excited about. 43% of the design ins that we had have converted to design win. You know, I can just tell you that that's a stronger number than I'm used to.
Hey, Matt Prisco from Evercore here. I guess first you talked about that design into design win conversion rate. Can you give us some color maybe on the opportunity pipeline to design in conversion rate, why you're winning there, what you're seeing in those wins you're getting, and maybe where somebody goes for an alternate, what's happening there?
A couple of things I would say on there. First off, from the opportunity pipeline, that now has gone from, I can't remember where it started 5 years ago, but basically nothing to $40 billion worth of opportunity pipeline. More and more and more applications are converting to silicon carbide. The vast majority of EVs that are being designed or inverters that are being designed today have all switched over to silicon carbide. In fact, I've heard back from one of our big Tier 1 suppliers, one of the largest Tier 1 suppliers on the planet. This company deals with every car company on Earth, and his note back to me was 100% of their opportunities are silicon carbide. I, of course, would only see silicon carbide because I don't sell silicon. This guy would see everything, and he said everything's converting. And the second thing that's happening is this conversion to silicon carbide across the broader industrial markets. And so you're seeing more and more industrial applications converting to silicon carbide for these reasons that I had mentioned about earlier, which is, you know, it's more efficient, their systems are better, they can meet their ESG goals, and quite frankly, they see a company investing in silicon carbide capacity when they hadn't seen that in silicon for a while. So that kind of has been one of the pushes as well from that perspective. So I think that's, you know, the thing that's driving that pipeline. In terms of the conversion, I think people are just trying to ramp their products as fast as possible. And really the governor on that right now is our own ability to expand capacity. And as Neil mentioned, we actually anticipate that this is going to, you know, we're going to be chasing the demand with supply probably through the end of the decade.
And then on the CapEx side, I think you guys talked about greater than $2 billion in a couple of years. Is that gross or net? And when you think about all these offsets that you walked us through, can you help us kind of think about the magnitude of what those can look like?
Yeah, so that's a good question, Matt. So when you think about right now, that is a net number. However, there's still a lot from a government incentives perspective that is yet to be known. So we did see the CHIPS Act was passed, which was great. We saw the ITC tax credit in the US was passed. We've seen other programs in Europe that are working their way through the system right now. How those programs will actually manifest themselves are not known, but everything we've seen to date is very positive. So we'll just have to remain flexible in terms of how we approach that. However, regardless of the government incentive packages that we'll see, there will be an investment that we'll have to make that will be required, and we will want to do that in advance of some of these pickups in CapEx that we will see, you know, in the not too distant future. And again, dilution is very much on our mind, and targeting those, you know, out of the gate, targeting those, you know, lower or non-dilutive methods is what we're really focused on right now.
Hey guys, thank you. It's Matt Ramsey from Cowen. A couple of questions. My first one, Greg, I think you guys have laid out a great case of economies of scale, experience, getting to 200 millimeter quickly, advantages on the material side that are, I guess, bad pun, but material. There are other parts of the equation of getting into the devices business that I'd like to hear you talk about. Some of your competition has silicon IGBTs and SiC, maybe more experience at scale in packaging, converting device fabs rather than building new ones that might lower their costs. As you've done analysis going out and these forecasts of your big devices business growth, how do you think that sort of back end side of the competitive advantages for your competition versus yourself? Thanks.
It's a great question, and it's not lost on us that we have device competitors that have substantially more experience in manufacturing semiconductors for automotive, et cetera, and same thing with packaging as well, whereas we have a pretty vast experience on the materials side of things. So it's not lost on us. Basically, we're doing two things. One is we're taking that advantage on the materials side of things, at that scale advantage that we have, and amplifying that. We've been doing that over the last 5 years by doing long-term supply agreements with folks. You're seeing that in Siler City. You're seeing that in us moving from 150 to 200 millimeter, silicon carbide crystals. And as you saw from Elif's presentation, the quality of those crystals is pretty good. So we're super excited about where we're at on that. The fact that there was one dot in the middle on defects versus, I don't know, half a dozen or something like that is a big deal. And so, the team's super excited about that. So from the materials side of it, we're taking the strength and the scale advantage we have, and we're amplifying that. You're seeing a 10x increase on that materials factory out of Siler City, and switching from 150 to 200. On the device side of things, there's a couple of things going on. One is we're introducing the world's newest and largest 200 millimeter silicon carbide wafer fab. Fully automated wafer fab, new innovation going into the production at 200 millimeter. I believe the second newest 200 millimeter brand new wafer fab is going to be something like 20 years old. So just in terms of comparison perspective, we have a very highly automated brand new 200 millimeter wafer fab, and you heard from Adam. Yields are already in really great shape. Cycle time, you saw what he was doing on cycle time. He's darn near where he wants to be from a cycle time perspective in a very short amount of time. We cut a ribbon on that fab in April of this year, and here we are in October, nearly at our target cycle times. Pretty amazing stuff. And then finally, I would say most of the industry right now is actually producing in 150 millimeter wafer fabs. I'm not sure exactly when the newest one of those is, but it's probably 30 years ago. And so what I would tell you is we have a very unique advantage in being able to start with greenfield, because we have a fab, as Adam talked about, that's completely and totally built with silicon carbide in mind. The second thing we're doing from the device side of things to shore things up is we're bringing in people with experience on large-scale device manufacturing. Lisa was up here talking about, putting in a quality infrastructure, et cetera. Missy came from a large device manufacturing company, has 20 plus years of experience, and kind of knows what good looks like, if you know what I mean. And so we're actually bringing in dozens and dozens and dozens of people from the outside to shore up that side of the equation. And I can tell you this, it's a lot easier for us to find experience in large-scale silicon manufacturing than it is for others to find experience in large-scale silicon carbide materials. And so that's kind of where we're going on that.
No, thanks, Greg, for all the detail there. I appreciate it. Question for Neil. I guess two. One of them was funding, but it didn't seem like we're going to get a ton of new detail today. So I'll punt that one. But the other question I got since the earnings call last week was the new gross margin headwind that I think we all learned about regarding the 100 to 150 transition in RF. Maybe you could just talk about the puts and takes there, how long that might take to be realized. Is it permanently off the table? Was it always part of your margin trajectory forecasts? And if so, it was a little disappointing to some that wasn't flagged earlier, so we could have anticipated it. Thanks.
Understand. And on the 100 to 150 millimeter transition, if you go back, first of all, if you look at it in terms of the context of communication, It's 300 basis points in 24, but it's closer to about 100 basis points as you get out in time. So it wasn't really a building from a low to mid 30s at the point in time when we talked about this previously to growing to 50% in terms of what we were communicating. What we've seen though is an incredible amount of demand over time. So that was one program that we had in there, one of many. And that program was supposed to be, if you look back, we were going to take our Durham capacity and from a power device perspective, lower it down and then push everything into Mohawk Valley. At that point in time, we were going to bring in our 150 millimeter RF opportunity into the same factory. What's happened is that because of the steady demand increases, we have not been able to have any downtime on the Durham fab. In fact, that's where we have unfulfilled demand. So we are going to have to delay that transition. It's something we're capable of doing, but we just don't have the downtime to make the transition. So that's really the background on it. We were looking for ways to go execute it over the last year. And it really was a program for 2024, so it's not really related, I don't think, so much to the guidance we had on the 2023 gross margins. But as you go out into 2024 and beyond, we'll just delay that. Now, over time, we should be able to find an opportunity to make the transition. But again, it becomes a less impactful discussion because the value of it just becomes smaller as you think about it, as getting into that kind of 26, 27 timeframe.
Jed.
Hi, thanks. Jed Dorsheimer from William Blair. I guess two questions. So first, as we look at, maybe Neil, I don't know if you want to address this one, but in terms of the $4 billion for 27, if we look at Mohawk Valley, you had the ability to kind of take that up a few different times with pulling in CapEx, et cetera. So as you think about Fab 2, is that have the same type of opportunity, or is the 2.6 sort of a pretty tight number around that?
I would say similar, Jed. I think if you think about Mohawk Valley, what we had said previously was it could generate between $1.5 to $2 billion of revenue. What we're saying today is it's approximately $2 billion, so we're getting a lot of faith in what we're seeing, and the yields that we're getting out of the factory give us a lot of confidence that we can achieve towards the higher end of that range. And that's from where we sit today. I would say for the other fab as well, there could be opportunity as well. We haven't actually built anything yet. So once we get results there and we start seeing that benefit, we should be in good shape. But I will say this, and I'll go back to what I said before. I see this as a blueprint. If you go back a couple of years ago, we were still developing our 200 millimeter technology. We didn't have a process technology for 200 millimeter substrates in a fab. Today we have that. We have 200 millimeter crystals. We have 200 millimeter processing, and we are in the midst of ramping 200 millimeter in a large scale production fab. So as we go to the next fab, that transition is going to be, nothing's easy, but it's going to be a lot easier. We don't have to develop the science behind a lot of it. We'll take what we've done in Mohawk Valley and we'll leverage it. We'll just do the same thing at a bigger scale.
That's helpful and a great segue into my follow-up. So, and maybe this one for you, Greg, but we're seeing an unprecedented amount of capital for reshoring, whether it's here domestically or over in Europe. And a lot of that money, excluding CHIPS Act, is largely targeted on natural resources. So, copper or lithium or processing. Silicon carbide is an interesting technology as it improves efficiency and gives optionality, which would ostensibly reduce any of those materials. And I'm just wondering, with the 200 millimeter advantage, which would be akin to TSMC sort of breaking through 10 nanometer, is capital the biggest limiting factor? And I mean, Neil, you showed the CapEx to rev and cash on cash return, which is 2 times better than silicon. I'm just wondering what the limiting factor is with a demand scenario that's far greater than the supply. Why it's looking at 1, why not 2 or 3 or whatever the number may be? Or is this just sort of a crawl, walk, run strategy?
I think it's more the latter. And so we're aware that we're in a very unprecedented situation, where we're showing a 40% compounded annual growth rate that takes us to a 40% adoption of electric vehicles by 2030. And it's probably going to keep adopting after that. So you can think of a compounded annual growth rate going for a decade or something like that. At that rate, is quite unprecedented. It may be the largest single growth of any technology in the history of semiconductors. You know, I don't know that for a fact, but I mean, sure does feel like it on a daily basis. And so we are very prudent of the fact that we need to make sure that we've gotten Mohawk Valley working the way that we want it to go before we start going with the second one. And we obviously saw the results today look quite good. Same thing with 200 millimeter. We're in Durham with 200 millimeter. We wanted to make sure the 200 millimeter, you know, wafers and the substrates had the right quality. You saw that today from Elif, and now we'll be moving forward with Siler City. And so it's kind of the same thinking that, you know, we're a relatively small company compared to, you know, some of the big juggernauts. And so Intel, I think, is going to do 4 or 8, I can't remember, you know, different fabs kind of simultaneously up in Ohio. We just can't do that. So we're going to do Mohawk Valley, get it moving. Once we get it moving, we got this next one all lined up. And I would say, kind of back on the first part of your question, we've had a chance to talk to a lot of industry people and a lot of government people about funding, both in Europe and in the US. And the way the officials kind of talk to us is, well, okay, you're in an industry that's growing like crazy. You're supporting a greener version of those industries. You're supporting a more efficient version of those industries. We're kind of a unicorn in that regard. So I think, you know, to Neil's point of, we don't have a whole lot in the CapEx plan on funding from government, but I think we're going to find that we're going to be able to get, you know, some pretty good funding from that perspective.
Yeah, hey guys, Harsh Kumar, Piper Sandler. Thanks for hosting an extremely informative Analyst Day. I'm going to take Matt Ramsey's punt question on funding and see how far I can go with that. So Neil, you talked about project financing, you know, other non-dilutive ways of financing. I was wondering if you could provide us with a theoretical framework. And the reason why I'm asking is this is the only question that I'm getting in the last 4 days on your company. So what is project financing? What is private financing? Is there debt kind of money even available to you? Because some investors are questioning, you know, because you don't make money, you have negative free cash flow. Is that even a viable option? And then I had a follow-up.
Yeah, I think, you know, it's exactly what I said, Harsh. I think that I understand the need for an understanding about exactly how these frameworks are going to work. I think as you work your way down from government funding to customer funding, which I think will play an important element over time as well, you start getting into this, I guess you could, as you split it up into either debt-based or you get into equity-based financing. I guess that's the way, you know, we can think about it. The conversations we've had so far in that kind of either private financing or in the project financing buckets have been very, very good. There is access to capital in these areas. We've seen other companies execute various programs. Now, I'm not saying that we're going to execute something that's similar to what someone else has done, but we do have a large array of things available to us that are possibilities for us to execute. But I think that'll come in conjunction with the other pieces as well. I think that it'll depend on how these government incentives work. It'll depend on the timing of receipt of some of those payments we can get from governments over time, the magnitude of those, that will all change the CapEx plan. So we're going to remain very, very flexible in our approach and how we go execute this. But yes, our target right now is to focus on lower dilution type of financing. And we want to get ahead of that between now and when we start seeing those CapEx numbers start to pick up in the back half of the fiscal year.
Thanks, Neil. Very helpful. And for my follow-up, you mentioned that the Mohawk Valley facility is basically sold out. So when you talk about customer assurance money or funding coming from those options, I was hoping you could help us with some sort of an understanding of the magnitude. Are we talking tens of millions of dollars? Are we talking hundreds of millions of dollars when you talk about filling up a fab like Mohawk Valley with $2 billion of revenues? Thank you.
You know, I'll probably stay away from details on that. Because most of the details are, you know, private between the two companies and so forth. What I can tell you is the amount of funding that we're talking about definitely requires board of director type approval. So it's not small amounts of deposits or things like that. It's substantial. Some are more substantial, than others. And it's also important to know that, when we talk to customers, we tell them that we're going to need to build another wafer fab. And, there's going to be more funding, et cetera. And so they understand most of these customers have gone through 2 years of a lot of grief, in trying to get silicon semiconductor chips, primarily due to the lack of investment over the last couple of years to deliver that. And so they see us, developing these fabs and putting these fabs into place, and they say, well, at least their kind of money is where their mouth is. And so it's a little bit, we have kind of a little bit of a different situation, because recall, we announced that we were going to build the world's largest silicon carbide wafer fab in May of 2019. And in May of 2019, there wasn't anybody talking about silicon shortages and semiconductor shortages and supply chain issues and things like that. And so today, we had talked earlier, and Adam had talked about customers coming through that fab. We get to have customers go through a fab and we say, well, we started this 3 years ago. And we kind of did what we said we were going to do. And so when we talk about there's going to be a new fab and we're going to put that into place so that's ramping in 2027, there's a credibility that we've earned on that. And so they're thinking of, I could put some money into this and get a guarantee out of it. There's just stronger credibility from that perspective.
Thanks so much. Colin Rush from Oppenheimer. Can you talk a little bit about the evolution and diversification of the device design process for you guys internally in terms of how your customers are looking at different needs and the cadence at which you're going to be evolving some of those offerings?
Well, maybe I'll kick it off, and if Jay, if you're around, you want to come on up, you can add a little bit more detail to this. Jay Cameron runs our power business. We're constantly evolving our product lines to look at what customers need today, what they need in the future, how do we eclipse the two, and so forth. And it's very much a partnership role. We've done that with JLR, certainly in terms of what are the future needs and so forth. Their engineering teams have been very open with us. And the best way to have a great solution for the customer is to have the engineering minds that know what the future demand is going to look like, meet with the engineering minds that know what potentially we could supply. So maybe Jay, if you want to add a little bit of color to that.
Yeah, thanks. Really appreciate the question here. I think what Greg talked about is really that customer relationship as the foundation for how we can apply our technology to achieve more value for our customers and products. So we're constantly having conversations about how we can bring the fundamental silicon carbide technology advantages and translate those into value propositions for our customers. We see that in the automotive industry with the focus on extending range, improving power density so that you can have more flexibility for industrial design of the car to give more cabin space and just better customer experiences. We see it in the faster charging times. And in the industrial and energy arenas, we see I'll say a very fragmented opportunity to, again, focus on the major value drivers that silicon carbide can offer with power density improvements, smaller size, smaller weight, and then that overall efficiency, which leads to improved costs of running, costs of operations, things like this. And so it's really taking those same fundamental values and just applying them to different end markets, different end applications. But the heart of it really comes from our sales team and our customers and our product experts working together to identify what those sources of value are and how we can evolve our portfolio to better serve that.
Thanks, Jay.
Thanks so much. And I guess my second question is really around, you're going through basically inventing or, building out this industry, not necessarily from scratch, but in a massive scale up. And what we've seen historically with this sort of scale up is there's a lot of coordination across the supply chain. So I appreciate the comments around culture and quality, but can you talk a little bit about risk management around this sort of scale up in the planning process? Because it seems like between COVID and the scale up of the industry, there's a much longer planning cycle than you normally would engage with.
Yeah, so we were pretty much ahead of that, I would say, because I can tell you when we announced the building of this wafer fab in May of 2019, That was at a conference in Germany. I personally reached out and had meetings with some of our suppliers of some of the raw materials at that time. And I said, look, we got this giant factory happening. It probably means we're going to need a lot more material from you. How do we have better relationships with you so that you feel comfortable investing, and so forth? And I can tell you, one of those companies that we met with back in May of 19 just came into Durham last week before last, can't remember. And we had a meeting with them, and they recall back to that time saying, you guys predicted this, you gave us a heads up, we started investing on it. And then very, very importantly, when kind of all hell broke loose in March of 2020, and everyone stopped doing stuff, and COVID and lockdowns and all this kind of stuff, we proactively reached out to all of our suppliers and said, don't blink. We're here with you. We're not going to be, messing you around or anything like that. And they all felt that as well. And that was a pretty consistent theme through our supply base. We're continually meeting with these suppliers, talking about what our plans are. And I tell them what we like in terms of doing business with our customers is long-term partnerships, and we want to do the same thing with our suppliers. And so when you do that across the board, you get a whole lot of better support as you're trying to grow this business.
Jack Egan, Charter Equity. So Wolfspeed's total design-ins are $15 billion, and if you combine that with similar values from ST Micro on Semi, the other big power device companies, it's a pretty significant chunk of the broader power semiconductor market. And so, how much of the growth in silicon carbide over the next decade do you expect is going to be the substitution effect of taking share against silicon IGBTs versus expanding the total power semi TAM by enabling new applications?
I can't give you the exact number. I can tell you that the conversion from silicon to silicon carbide is happening at a very, very accelerated pace, way faster than I would have anticipated. And in the auto industry, I can't name a single car company that's planning right now an inverter that's going to go in production into a car in 27, 28 that's silicon. I don't see all the silicon ones, so maybe there are some out there, but when I hear from our tier one suppliers, they kind of echo the same thing back. That transition to silicon carbide is near complete. Across the broader industries, Aero Electronics, working with us to go, service that market and so forth, and doing a good job of designing things. And they're seeing a similar kind of thing where, in that case, some of those companies just can't get any silicon chips. So they've told the purchasing guys have told their engineering teams, we might as well go ahead and make the shift to silicon carbide. We're going to have better products, more efficient products, and we got a fab that's going to be going into production. So I would say that, largely, Jack, I would say that it probably leans towards a conversion from silicon to silicon carbide as opposed to expanding the market, but it's definitely expanding the opportunity for silicon carbide inside of that.
And I would just add to that, Greg. I think if you look at, and I should have answered Gary's question, maybe start off with something a little bit different. The market itself and the size of it is very hard to determine. So talk about share even is very difficult. But the one thing we do know is we're winning a lot more from a design-in perspective than we anticipated a year ago. And what that translates into, so we go to customers, we meet with JLR, for instance, and we go into their meetings. The first thing they ask us about is like, this product line on this date, are you on track to meet it? So they're counting on us to meet those objectives. And what that means is that our factories are already full based on those design-ins we have already won, or close to it with some, I think, reasonable assumptions. So while the market may be hard to call, and it is just based on how fast it's growing, what we do know is that the design-ins are creating a revenue growth trajectory that customers are counting on us to take and deliver that into product over time. And that's really what we're focused on. We'll see how the market dynamics play out, but clearly driving to a point where we can deliver products for our customers is really where we're headed.
Thank you, gentlemen. Appreciate that.
Thank you.
Maybe step here.
Now we're going to start our final segment of today that we're really excited about. We're going to start with a little video and then we'll get going.
Jaguar Land Rover is the creator of the world's most desirable brands: Jaguar, Range Rover, Discovery, and Defender. Through our reimagined strategy, we are transforming into an electric-first, modern luxury business. And together, with industry leaders, pioneers, and innovators, we will create inspirational, exclusive, and exceptional experiences for all of our clients around the world.
And to you.
Well, I would like to first off welcome Thierry Bolloré. He is the CEO of Jaguar Land Rover, and he's joining us via video link from the UK. Thierry, welcome.
Thank you, Greg. Hello to all of you. Very glad to be with you today.
Well, this is terrific and very exciting. And Thierry, we've had a great morning of talking about the promise of silicon carbide, the amazing partnership we've announced today with JLR. But I'm going to turn to you first, and thank you again for joining us. It's a very exciting announcement in what we talked about today. But as we're looking forward to be part of your partnership network, could you give the audience just a little bit more background on the electrification journey and the Reimagine program?
Well, thank you very much, Tyler. For sure, with great pleasure. Reimagine for us is our strategy, which is really bringing a clear roadmap for the future of Jaguar Land Rover. The first point of Reimagine, of course, is to create the maximum value, but the maximum value for our clients first, and of course, to our stakeholders and to our company. That's very clear, and our shareholders the same. But it's to do that by delivering our vision of what is modern luxury, and in fact, becoming the proud creators of the most desirable brands, vehicles, and services for the most discerning clients and customers. The second point we have in our Reimagine strategy is to make sure that Jaguar is becoming fully electric by 2025 only, and making sure that Jaguar and the new portfolio of the new Jaguars, very distinct from the portfolio of Range Rover, Defender, Discovery, that new portfolio is also a copy of nothing, which is the absolute essence of our brand. So not only Jaguar, but also Range Rover, Discovery, and Defender, they will have from 2024 onwards their pure electric versions. So you understand that Reimagine is also bringing us in the leadership in terms of technologies, in terms of services, and making sure that all this is being driven towards absolute utmost experience for our discerning customers and clients. And the intimacy that we want to build with each single client is also at the heart of Reimagine. All that, of course, being driven to a carbon net zero by 2039. Another key element of Reimagine is, of course, to create a complete new paradigm where we move from a traditional supply chain to an end-to-end value chain approach. We can see since the pandemic the extraordinary strains on global supply chain. And that's also the reason why we absolutely need, with these new portfolios, as well of Jaguar, as well of Land Rovers, we need to make it such that we simplify our value chain, that we select the partners who we want to be the leaders in their field. And these partnerships will secure our position to be the best in the best-in-class technology. We absolutely need to master our control points of this new value chain, which is the future of the mobility business. New value chain in terms of drivetrain towards electrification, but new value chains as well in terms of connectivity, in terms of ability to deliver incredible services, especially in the field of modern luxury. So new ways of working based on trust, desire to develop together the best solutions, sharing information and accelerating innovation. Co-creation is at the heart of this new paradigm to offer the most advanced technology for modern luxury vehicles.
That's terrific, and thank you so much. And Greg, it's certainly an exciting time to be part of the JLR family and on the cutting edge of EV technology. But what excites you about working with JLR and the opportunity to further their electrification journey?
Well, thanks, Tyler, and thanks, Thierry, for your opening comments. First off, we've been working together with JLR since 2017, and so the teams have had a technical relationship for quite some time, and it's been a very positive feedback. And then I would say that the reimagined strategy and the new direction of JLR coincides directly with the direction that we're going. And the opportunity for us to kind of think differently or reimagine what a relationship could look like between a semiconductor company and a car manufacturer, I would say the team at JLR has really taken some very strong steps forward. And I remember the first time we got together to talk about what could a different relationship look like. I remember both teams left that meeting going, wow, you had me at reimagine. It was one of these things where we both realized that the directions that we were both driving was going to be great for both companies. We have a leadership position in one of the key and crucial elements, to help drive the electrification of the vehicle, and that is the silicon carbide technology. JLR has a whole strategy to completely move towards electric first, and of course, and the Jaguar line go all electric. And so this notion of we are all in a partnership way with a company that's all in with the technology to get us there is going to be really key. I also remember the first time we had the leadership team, including Thierry, visit the Mohawk Valley fab and showing them, of course this was before it was completed, showing them what the future of silicon carbide manufacturing could look like and what the scale of it could look like. I think this became an integral part of the decision process of, you combine the technologies are right, the culture of the two companies are right, the way we're thinking is right, and then the underpinning, investment that we're making in a manufacturing, capacity is also right. JLR's European roots and its broad scale across the globe also gives us a lot of confidence in partnering up together, and we look forward to a really beautiful future together.
Thanks, Greg. And that's a terrific segue back to Thierry. When you folks were thinking about a partnership, why did Wolfspeed seem like the right fit?
Well, I think it's quite clear in our mind, and without repeating what Greg said about the history of the two companies, that semiconductors play a phenomenal role in electrification, and beyond electrification, in all what I've described to be part of the reimagined strategy. It's an absolute key control point on the new value chain, and the more it goes, the more it will be the case. It is fantastic, to be honest, when I discovered that both companies were really not strangers, that thanks to this cooperation in racing activities with Formula E since more than 5 years, in fact, our teams knew each other very well, very well. And it has been absolutely demonstrated in those 5 years that silicon carbide for inverters optimizes the performance of electric vehicle to a level which we have discovered and rediscovered, because it's a permanent progress. This is where the beauty of a great cooperation has shown even recently. And I could see and I could listen to our teammates from both companies having specific technical meetings, to prepare the races and exchanging about how they could get more performance. And this openness, from both sides, sharing data, sharing ideas, etc., has created an incredible differentiation in racing. So now our goal with Wolfspeed is to go from race to road and to make it such that what we are preparing with new Jaguar, Defender, Range Rovers, and Discovery, they're going to take the full benefits and permanently improved of this cooperation within this partnership. So that's what I can see, and I can see today, from yesterday, today, and for tomorrow.
That's terrific. Okay, so now for the tough question. It's one thing to toast glasses and celebrate a partnership, but Greg, what is Wolfspeed going to do to remain in lockstep with what sounds like a very exciting but a very fast-moving plan at JLR? So what have you talked about with the team to ensure that we're going to kind of keep our promises and do everything that we're discussed today?
I think the first thing is transparency, and there's been a ton of transparency between the two teams. Jay, who you saw just came up for to answer a different question, was actually in the UK last week, meeting with the team to talk about kind of how is the governance going to work on this, and how often should we meet, and when should we bring in the CEOs, and so forth. And so all of this is an ongoing discussion. Of course, Thierry has my personal cell phone number. He can call me anytime he wants, and same thing, vice versa. So I think having that connection and that ability to say, we have a challenge, we need to go work it. And Thierry and I had a really nice discussion a little while ago where we were talking about challenges and problems, and we both came up with basically the same philosophy that said, the problem is never your problem, and the problem is never my problem. The problem is the problem, and we need to work together to solve it. We know there's going to be challenges. There's going to be a zillion challenges as we ramp these technologies, but we're both committed to go after it. I think the second thing is that the team sees that we're very serious about expanding capacity. They saw that quite a while ago when Mohawk Valley was in the early phase of construction to now you see it today, and you see automation and the machines working and so forth, to seeing what we're doing in Siler City. And I had a chance to brief Thierry on that ahead of that announcement, and super excited about the fact that on a Friday, we make an announcement, and on a Monday, we have trees being removed and earth being flattened and all of this kind of stuff. So this kind of serious intention we're going to go after that very, very aggressively. The ramp in capacity, as I said, is going to be unprecedented, and it's going to have challenges. And as I said, we'll face those challenges together. The JLR team has been just terrific to work with along those avenues, but also, and very importantly, on the technical exchange side of things that we mentioned kind of earlier. Jay and the team working with the team at JLR to really understand what are the fine corners and what could we do to make a small improvement over here that would make a huge improvement over there. And there's a lot of transparency in that, and I think it's going to be a great journey. We're super happy to be partnered with such a strong and leading brand, and we're super excited about the Reimagine strategy and the whole journey that we have forward together.
Thanks, Greg. And Thierry, I'll turn back to you just for your thoughts about how Greg talked about partnerships like this one between Wolfspeed and JLR, and how they can be successful. How does this type of relationship ultimately influence the electrification movement going on in the broader automotive industry?
At the end of the day, this choice of partners for us is absolutely paramount to succeed with our Reimagine strategy. And we are super proud that this partnership with Wolfspeed on inverters could take place for the historical and actual reasons that we have explained, Greg and I. I think ultimately, not only we are looking for the best partners, and Wolfspeed is one of the best, otherwise we will not do it. But in addition to that, it's a story of human beings. It's a story between people. It's a story between teams with a mindset, with an approach in terms of, as we say here, we say speak the truth. It's beyond transparency, and it's more cooperation than collaboration. Collaboration you can have two silos collaborating within each other, through contracts. Cooperation is exactly what Greg said, which means I'm taking care of your success as much as you are taking care of my success. So far, it becomes a team success, beyond expectation. That's exactly what we are doing and what we want to do furthermore in the future. And all that is based on of course, trust, shared interest to deliver for us the most desirable luxury vehicles in a carbon net zero world. This is what we want to do together.
Well, thank you. Well, I thank you both. This has been a terrific opportunity, and thank you again for the opportunity to serve your business. So thanks, everyone.
Thank you, Thierry. Thank you very much.
Thank you, Thierry. Goodbye.
Well, that is the conclusion of today's investor update. We really thank you for your time. As I mentioned at the beginning of the day, we're going to be back outside for about the next 30 minutes or so to take any additional questions. And thank you again for joining us.